Hi everyone and welcome to this tutorial session. Today we want to solve this question under real valued functions. Given the two functions g and h defined as g of x, that's the function g takes x and maps to 1 all over x plus 2. H takes x and maps to 3 minus x. 3 minus x. In this first definition, we say x belongs to the set of real numbers except the singleton -2. Here, x belongs to the set of real numbers. We are given these two functions, and then we are asked to, for the first part, define in a similar manner the functions g of h and h of g. All right, let's start with g of h. G of h simply means g is going to implement h of x. Now, what are the instructions in g? If we look at g carefully, all right, we look at g of x. This expression written in the shorthand form will be g of x is equal to 1 all over x plus 2. It simply means whatever g carries is going to take a reciprocal of 1 of that thing plus 2. Okay, so g is carrying x here. This is what it does to it. But here, g is carrying h of x. So we expect g of h of x to follow the same definition of g, the instructions in g. The instruction in g says we put 1 at the numerator. This is it. At the denominator, the thing that g is carrying x, but now it's carrying h of x. So we'll put h of x plus 2. All right, so this gives us 1 all over, we know h of x, that is g of x. H of x in shorthand form, this is the expression for the function h. H of x in shorthand form will be h of x equals 3 minus x. All right, so here we're going to write 3 minus x, then plus 2, which simplifies to 1 all over 3 plus 2 is 5. So we have 5 minus x. All right. So that will give us our g h of x. All right. So our g h of x is equal to this. But remember, the question says expressed in a similar manner. We look at the manner in which h and g has been defined. Look at that manner. So we want to define this in a similar manner. So we now say in a similar manner, we'll look at the manner in which g of x was defined and h of x was defined. We'll start with the letter of the function. So here we have the composition gh, followed by column, followed by the variable, arrow, and then the expression 1 all over 5 minus x. All right, comma, and then the domain. Now, what is the domain of this function? We know that dividing by 0 is not possible in mathematics. Therefore, we'll exclude the value of x that will render this denominator 0. How do we do that? We simply set that denominator to 0 and we solve. This is negative x. Taking it that way, we obtain x equals 5. So this is the value of x that will render this denominator 0. All right, if you look at it carefully, if you put 5 there, 5 minus 5 is 0. So 1 all over 0 is undefined in mathematics. So the domain of this function, remember, we are defining it in a similar manner. The domain of this function will be all real values of x such that x belongs to the set of real values except, all right, this subtraction means except the singleton 5. 5. Okay, so that answers the part which says we should define g h of x in a similar manner. Then what about, so let's write our g h of x up there because we're going to need it in the second part of our work. G h of x is 1 all over 5 minus x. All right, let's keep it there. Now, the second part, we also have to look for hg of x. Hg of x. Our g of x remains the same. The shorthand form of our expression for g of x remains the same. Now, hg of x. Hg simply means h is going to be the outer function here now, and inside we're going to have g of x. This is our g of x, this is our h of x. So what is h of g of x? H of g of x means we are going to implement the instructions of h. All right, look at h. What's the instruction? Whatever h carries, all right, is subtracted from 3. So h has one instruction. All right. So what is h carrying here? It's carrying g of x. It's going to do the same thing. It's going to subtract g of x from 3. So hg of x will just be 3 minus g of x. All right. So what are we saying? We're simply saying that g of x takes the place of x in that expression. That's all. All right. So that's it there. But we know g of x. So it will be 3 minus, this is g of x minus 1 all over x plus 2. Okay. Now to make it compact, this is a fraction. We just make this one a fraction. The LCM will just be their product. 1 multiplied to that expression is simply the expression. All right. X plus 2. X plus 2 divided by 1 is x plus 2 multiplied by 3. So we write 3 into x plus 2 minus x plus 2 divided by itself is 1. 1 times 1 is 1. So this gives us, open that parenthesis, 3 multiplied to 1, 3 multiplied to x is going to give us, 3 multiplied to x is going to give us 3x. 3 multiplied to 2 plus 6 minus 1 all over x plus 2. This gives us 3x. 6 minus 1 is 5 all over x plus 2. All right. So this is the expression for hg of x. Now, in a similar manner, we're going to follow the similar manner again. We have the letter, column, the variable, arrow, and then the expression. And then now the domain. Okay. So what is our letter? Our letter is hg. Look at it, hg. So we say hg, then column, then takes x, maps to the expression. This is the expression. We have 3x plus 5 all over x plus 2, comma, and then the domain. What is our domain? Look at the denominator here. We have x again there. So we have to exclude the value that will make this denominator 0. What value is that? To get that value, we simply set that denominator to 0 and solve. So we have -2 will be that value. The value to exclude is -2. If x takes the value -2, we'll have -2 plus 2, which is 0. Dividing by 0 is impossible in mathematics. All right. So the value to exclude is -2. So, comma, then we now say x. Remember, we're following that same manner. X is a real number except -2. Okay. So hg of x in a similar manner will be written as such. Since we will need it in our next part, let's also write hg of x here so that we will not mix up things. It's equal to 3x plus 5 all over x plus 2. Okay. Question B. Let's go to question B. Question B says, find two three significant figures the value of x for which gh of x is equal to hg of x. Gh of x equals to hg of x. This is the equation we want to solve. Okay, we want to solve that equation. Now we have our gh of x written there. So we simply put it here now. 1 all over 5 minus x is equal to hg of x is also written there. 3x plus 5 all over x plus 2. This is the equation we have to solve. It's a rational equation in terms of x. The left-hand side is a fraction, the right-hand side is a fractional expression. So how do we go about this? How do you go about this? For this expression to be well defined, we all know, all right? For this expression to be well defined, we all know that this denominator should not be 0 and this denominator should not be 0. We should take note. For this denominator to be 0, we have to exclude 5. 5 minus 5, 0. For this denominator to be 0, we have to exclude negative 2. Negative 2 plus 2 is 0. All right? So, comma, we know that x should never be a member of negative 2. Can never be either negative 2 or 5. Okay? From the definition that we had earlier, x should never be negative 2 and x should never be 5. So we already know whatever solution we get here, these two values cannot be valid as a solution to this rational equation. All right, from there now we can now carry out what we call cross multiplication. This denominator will multiply that numerator, this denominator will multiply that numerator. All right, so we have 1 multiplied to x plus 2 is equal to this expression multiplied to that expression. 5 minus x into 3x plus 5. All right, so 1 multiplied to anything, we just have the same expression. Now open up this parenthesis. 5 multiplied to 3x is 15x. 5 multiplied to 5 is 25. Negative x multiplied to 3x, negative 3x squared. Negative x multiplied to 5 is negative 5x. We are beginning to see a quadratic in terms of x. The highest power is 2. So we have to rearrange everything to obtain the quadratic that is hiding. So let's bring like terms together. I'll prefer we take everything from the right hand side to the left hand side in order to obtain a 0 on the right hand side, because I'm seeing negative 3x squared here. This is the leading term. I always want my leading term to be positive. So to obtain positive 3x squared, I simply have to carry it this way. Now, therefore, it means that to arrange my work in the best way, I should just take everything that is on the right hand side to the left hand side so that I have a 0 on the right hand side. These ones were already here, so I just write them there. X plus 2. This is plus positive 15x. Coming over, it becomes minus 15x. This is plus 25. Coming over this way, minus 25. This is negative 3x squared. Coming over this way, plus 3x squared. This is negative 5x. Coming over this way, it becomes positive 5x equal to 0. Now we want to arrange everything. You remember the general nature of a quadratic equation is ax squared plus bx plus c equals 0. That's the general nature of a quadratic expression or quadratic equation. We'll start with the leading term. This is our leading term. So we have 3x squared. We'll now go to the x term, the things in x. We have this, we have this, we have this. Okay? So we have plus x plus 5x minus 15x. All right, the ones that have ticked. Now we'll now go to the constant. The thing that does not contain the variable, we have just plus 2 and then negative 5, negative 25. So we have plus 2 minus 25 equal 0. All right, so what is our quadratic? Our quadratic equation is 3x squared. X plus 5x is 6x. 6x minus 15x is going to give us negative 9x. Negative 9x. Okay. Then now 2 minus 25 is going to give us negative 23 is equal to 0. So our quadratic equation that we obtain is 3x squared minus 9x minus 23 equal 0. That's the quadratic equation that we obtain here. Now, if we collect our coefficients carefully in order to implement the quadratic formula, a is the coefficient of the leading term, 3. B is the coefficient of the x term, negative 9. C is the constant term, negative 23. We should be very, very careful with these coefficients. If we collect them, if we make a mistake at this level, then what we will obtain finally will be a very, very wrong answer. Now, applying the quadratic formula, x equals minus b plus minus the root of b squared minus 4ac, all of that divided by 2a. Okay, so coming over here, we'll now put our values of a, b, c in that expression. We have x is equal to negative 9 plus minus the root of negative 9 squared minus 4 into a times c, all of that divided by 2a. This gives us negative multiplied to negative is positive. So we have positive 9 there, plus or minus the root of negative 9 squared is 81. This negative multiplied to that negative become positive. 4 times 3. So we have 4 times 3 is 12. 12 times 23. So we have 6, 4, 3, 2. 270. All right. Divided by 2 times 3, 6. Am I right? Let's check again. 2 times 3 is 6, not 0. 2 times that is 4, 3, 2. So we have 6 here, 7, 276. So we're supposed to have 276 there. All right. So this gives us 9 plus minus the square root. 9 plus minus the square root of 81 plus 276. 81 plus 276. We obtain 7, 15, carry 1, 3. Okay. So we're going to have 357. Root of 357 all over 6. Okay. Root of 357 all over 6. So this gives us our two values of x that we're supposed to have. Our two values of x that we're supposed to have. The first one will be 9 plus this root, and then 9 minus that root. All of that divided by 6. All right. So from there, we expect you to be able to go ahead and get the answers in decimal form. All right. So that from here, we'll now be able to express our answer I'll now express our answers in significant figures. So let me just quickly do this square root, and we get the answer. Let us do the square root. Let us do the square root and we get the answer. Let me look for the calculator, please. Do the square root and get the answer. So 9 plus minus root 357. The root of 357 all over 6. Okay. Let's get the square root of 357. So we have 357 square root. We have 18.8944. All right, this is going to give us 9 plus minus 18.8944 all over 6. All right. Now, so we have for the first value, we'll take the positive 9 plus 18.8944 all over 6. 9 plus 18, we have 27.8944 all over 6. Now, this answer finally gives us 4.649. 4.649. We have 4.649. All right. Remember, the question says we should give our answers to 3 significant figures. The digit 4, the digit 6, the digit 4, the digit 9 are all significant digits. So this answer to 3 significant figures, we just simply count 1, 2, 3. All right. 1, 2, 3. We look at the digit immediately after the vertical stroke. It is above 5. So we round it up to 1 and put it here. And so our answer to 3 significant figure here will be 4.65. This first answer to 3 significant figure is 4.65. Now let's take the other answer, which will be 9 minus. So this one was 9 plus. We'll now take the 9 minus all of that. Let's do that quickly. The second answer will be x equals 9 minus 18.8944 divided by 6. All right, let's do the calculation. 9 minus 18.8944. Okay, we got negative 9.8944 divided by 6. So let's divide by 6. That gives us negative 1.649. Okay, so our next answer is negative 1.649. All right, again, to 3 significant figures, the digit 1 is significant, the digit 6 is significant, the digit 4 is significant, the digit 9 is significant. All of these digits are significant. So to 3 significant figures, we just count 1, 2, 3. I will draw a vertical stroke again, and see the digit after that vertical stroke again is more than 5. We'll run it up to 1 and put it there. And so our answer is just negative 1.65 to 3 significant figures. So our two answers to 3 significant figures are 4.65 and negative 1.65.